Hello students, I am Dr. NAVNEET KAUR, Associate Professor in Department of Electronics and Communication Engineering, SIRT College, Bhopal. In my previous lecture, I have discussed three properties of Z transform, that is linearity, time shifting, and scaling property. Now, in this lecture of signal and system subject, I'll be taking the remaining properties of the Z transform. Now, I'll start with the next property, which is time reversal property. Now, according to the time reversal property, suppose if I have any signal xn and it is having Z transform xz and ROC is between region R1 and R2. Then if I'll take the time reversed version of signal xn, that is folded version of signal xn, which is represented by x of minus n, then its Z transform will be x of z minus 1, z raised to power minus 1. And ROC will also be changed. Now, the new ROC will be between 1 upon R2 and 1 upon R1. Now, we will do the proof of this property. Now, starting with the property of the Z transform, the formula says that the Z transform is given by n is equal to minus infinity to infinity xn z raised to power minus n. Now, if I want to find out the Z transform of x of minus n, I replace xn by x of minus n. Now, I'll change the variable from n to L. I'll take L is equal to minus n. Now, when there is a change in the variable, there will be change in the limits also. So now I'll calculate the limits for this substitution. Now, when n is equal to minus infinity, L will be infinity. And when n is infinity, L will be minus infinity. Now, putting the value of the limits for new variable, L will be infinity to minus infinity, xl z raised to power L. Now, in summation, the order of the limits does not change the value. So, I'll take L is equal to minus infinity to infinity, xl, and z raised to power L will be taken as z raised to power minus 1, which is also raised to minus L. Now, if I see this right-hand side summation, it is same as the formula for Z transform. Only the difference is that in place of Z, I have Z inverse. So, this is the Z transform of xn, but with variable Z inverse. So, it will be given as xz inverse. Now, coming to the next property, which is differentiation in Z domain. Now, if I have any signal xn, which is giving Z transform as xz, and if I multiply xn with n, the Z transform will be given by the differentiation of this Z transform xz, and minus z will be multiplied by this differentiation. Now, coming to the proof of this property, I'll start with xz formula, which is n is equal to minus infinity to infinity xn z raised to power minus n. Now, I'll differentiate both sides with respect to z. I'll get dxz upon dz, d upon dz, and xn z raised to power minus n. Now, xn is independent of z, so I'll differentiate z raised to power minus n with respect to z. Now, here I'll get minus n, z minus n minus 1. Now, I'll take minus sign out of this summation sign, and here I'll separate the two terms z raised to power minus n and z raised to power minus 1. Now, z raised to power minus 1 is independent of this variable n, so I can take it out of the summation sign. Now, the next term will be now z inverse minus n xn z raised to power minus n. Now, I have also taken minus sign outside the summation. Here I'll get n xn z raised to power minus n. Now, if I'll see this summation, this is the formula for the Z transform of nxn. And so I'll write Z inverse as 1 upon Z. So I'll take Z here and minus sign also on the left hand side. I'll get minus Z dxz upon dz, and this is the Z transform of nxn. Now, according to this equation, it is clear that Z transform of nxn is given by left hand side, which is minus Z dxz upon dz. And this is the only property which I wanted to prove, that nxn is having z transform minus z dxz upon dz. And upon differentiation, there will not be change in the ROC. Now coming to the next property, which is convolution of two sequences. Now say if I have two sequences x1n and x2n having z transform x1z and x2z respectively. Now if I'll take convolution in time domain, which is x1n, and convolution with x2n. Here in z domain, both the z transforms will get multiplied. I'll get x1z into x2z. And ROC will be the intersection of the ROC of x1z and x2z. Now coming to the proof of this property. Now first I'll write the formula for the convolution of x1n and x2n. Say I'll represent it by xn. Now xn is given by the formula, which is k is equal to minus infinity to infinity x1k x2 n minus k, which is the formula which we have already discussed for convolution. Now, taking the z transform of x1n convolution with x2n, I'll take the formula for z transform and I'll put this convolution formula in place of the signal for which the z transform is to be calculated. Now, I'll write the formula for xn, which is z transform of xn, which is xn z raised to the minus n is equal to minus infinity to plus infinity. Since I want to find out the z transform of x1n in convolution with x2n, I'll put the formula for convolution in place of xn, which is x1k x2n minus k summation k is equal to minus infinity to infinity. Rest of the terms will remain same. Now I'll rearrange the summation terms. I'll take summation of k and x1k, then I'll take second summation of n and x2n minus k. Z raised to the power minus n will be taken along with this summation. Now, I'll take z raised to power minus n can be multiplied by z raised to power k and z raised to power minus k. Since z raised to power k and z raised to power minus k product will be 1, so it will not make any change to the term. So, I'll merge z raised to power plus k with z raised to power minus n, and z raised to power minus k will be written in separate form. Now, since z raised to power minus k is independent of n, so I can take it out of the summation sign. So I'll take it at z raised to power minus k, which will be merged with this summation. And here I'll get x2n minus k, z raised to power minus n minus k. Now in the second summation, I'll put n minus k as m. Now, since there is change in the variable, I will calculate the limits also. When n is equal to minus infinity, which is the lower limit, m will also be minus infinity. And when n is plus infinity, m will also be plus infinity. So now I'll put m is equal to minus infinity to plus infinity. In place of n minus k, I'll put m. So I'll get x2m z raised to the minus m is equal to minus infinity to plus infinity. Now, if I'll see the two summation, this is the formula for the z transform of x1n, and this is the formula for z transform of x2n. So I'll write it as x1z and I'll write it as x2z. Now, this proves that the z transform of the convolution of x1 and x2n will be given by the product of the two z transforms x1z and x2z. And ROC will be the common region of the ROC of x1z and x2z. And this proves the convolution property. Now, this is all for today's lecture. Thank you.